Revision will only get you so far in GCSE Science. Let's say you've revised roughly around a grade 6 to a grade 8 level. How do you make sure you get those highest grades and don't flop in the exam? That's all down to something called exam technique. Now, one important part of exam technique is reading the question, in particular the command word at the start of the sentence, really carefully. This applies for all of science. We're going to look at some you can see on the left-hand side here and look at what they mean and how you could be expected to answer them and not make common mistakes that loses you marks. So the first couple we should be fairly familiar with: describe and explain. Describe questions mean you say what is happening. Explain questions, you then say why it's happening. If you start explaining something in a describe question, it's not going to be wrong necessarily, but you're just going to waste time and waste space. The next question is calculate. That should be straightforward. Use a calculator to work something out. The next one, determine, can catch people out. That means determining something is usually using a graph or a piece of data in a calculation. The next one is suggest. So suggest is not an interesting one because it usually means it's something that's not on the specification specifically, but your answer will contain knowledge that you've got to apply to that specific scenario. So applying your knowledge to an unfamiliar situation, AO3, assessment objective 3 type questions. Compare questions, you're going to talk about similarities and differences, in particular using comparative sentences, like something is better, something is worse, something is weaker, something is stronger, not just descriptions. And evaluate, one of the trickiest ones is you've got to talk about the pros and cons of two or more different things and then usually come to a judgment about which one might be better. So let's have a look at some examples. These are going to be from GCSE Physics paper 1, but these apply to all the sciences, so it'll be really useful to improve your exam technique across all three sciences. So the first couple of examples we're going to look at are describe questions. So only saying what's happening, not necessarily why. If we start explaining, then we might lose marks because we might run out of room and not describe it properly. So in this question, we've got a drone being launched. It's a battery-powered drone. So the question's asking two changes to energy stores of the drone as it moves at constant speed. So as a bit of a revision, if it's at constant speed, it's not gaining kinetic energy. That means it must be moving faster. It is gaining height, so it's going to be increasing gravitational, and it's going to be decreasing its chemical energy store because its battery power is going to be draining. Next one, we're describing a relationship between length and resistance. Now from this graph, it's only a describe question. We do not need to start explaining it. It's really simple, 2 marks this one. It's a straight line through the origin. To just describe it, we're just going to say the resistance is directly proportional to length. If you want 1 mark instead of 2, you'd say length increases, resistance increases, but it's a straight line through the origin, shows us it's directly proportional. So that's all we need to do to describe that. Would be 2 marks in that question. We do not need to explain it. Let's move on to what we've got, an explain question. Now, explain questions, especially to do with particles, you really need to be careful with how you are wording your answers. So a lot of key terms in this answer here. So in this question, we've got the temperature is changing from 20 degrees to 0 degrees. Volume stays the same. This question is asking how the motion of air molecules cause pressure to change. Now, sometimes in explain questions, you do need to do a little bit of description, because actually in this question, it says the pressure changes. It doesn't say whether it goes up or whether it goes down. So in this question, we do actually need to get a mark for saying, well, as the temperature is changing, therefore the pressure is decreasing. Temperature is decreasing, pressure decreases. So that is 1 mark already. The other 2 marks are for explaining. So the pressure decreases, what we'd say is that molecules that are part of a gas that has less temperature have less kinetic energy. Less kinetic energy means, or you could say less speed if you wanted to, there are going to be less collisions per second, or fewer collisions per second with the wall. That would be enough to get your 3 marks. So you could say it's less frequent collisions. That's always a good phrase to say, which means there's going to be less force overall. But that's the 3rd mark in this question. Next, I'm going to talk about 2 states of matter questions. One where the question asks you to describe it. Another one, you've got to explain it and just look at the subtle differences between them. So in this question, it's quite an old 6 marker, but it only asks you to describe the arrangement of the sodium atoms as it changes from a liquid to a gas. So we are only making descriptions with this one. So this is a much easier question, in my opinion, than the explain question. So examples of statements we could talk about. So if it goes a solid to a liquid to a gas, we could talk about the atoms or particles are closely packed in the solid. They're in a regular arrangement. They vibrate about a fixed position. In a liquid, we can talk about the atoms are close together. They're not regularly arranged. They can move past each other. And a gas, the easiest one, they're well separated. They're not in a regular arrangement, or they're in a random arrangement, and they can move very randomly at high speed. That will be enough for a description. The next question we're going to look at, the explain question. I'm just going to show you one of the parts of the marks scheme that talks about what you need to do to get level 3 or 5 to 6 marks. means that it really, really clearly says it must be an attempt at an explanation of the changes that happen inside the part with the particles. So we're going to do some description because we do get marks to say what happens to the arrangement and movement of particles. It's a very similar question. It's talking about temperature of air decreasing. It changes just this time from a liquid to a solid, so we don't need to worry about gas. So let's talk about those descriptive parts first then. So as the argon cools, the particles slow down. The particles in liquid move slower. We could say the particles getting closer together, the density increasing, things like that. We could then talk about the gas to liquid. They go from spread apart to touching. They go from a random pattern to a regular pattern or regular arrangement. They are moving freely. Now they're in fixed positions, etc. However, this is the really tricky bit, explaining why does that happen. So we've got to link it to the idea of energy, essentially. So what we'd say is that basically the internal energy of the argon, so the gas we're talking about, is decreasing. So if you remember, internal energy is made of kinetic and potential energy. So we have to say the internal energy decreases, and that results in the kinetic energy of the particles decreasing with temperature. So temperature goes down, particles have less kinetic energy. As well as that, when the particles change state, or when the argon changes state, the particles are going to have a change in potential energy. Potential energy relates to how far apart the particles are from each other. So therefore, because they're getting close together, even though they might not be moving around more or less, we say the potential energy is changing. We can also talk about the forces acting between them being stronger when they're closer than a solid than in a liquid, which kind of makes sense. So there you go, that's a good example of describe and explain questions. Next one we're going to look at is determine. So this is the question from a physics paper about determine the resistance of a filament lamp when a potential difference is 3 volts. So we've got to use the graph and use the equation sheet. So first of all, using the graph, we can see we can got current and potential difference. From the equation sheet, if we're trying to find resistance, I've got the equation V equals I times R. Potential difference equals current times by resistance. At a voltage of 3, the current we can read from the graph is 0.16. So using our equation V equals I times R, I can then put those two numbers in, do a little bit of rearranging once we've got the numbers in, and figure out the resistance is going to be 3 volts divided by 0.16, which is 18.75 ohms. From experience, a lot of people missed out this question because they didn't use the graph. They just thought, oh, there's not enough numbers here, I don't know what to do. But you've got to use the graph or data if it talks about determining something. Next one, we're going to look at suggest. So suggest is an interesting one. Sometimes questions will say suggest a value or suggest a reason. That means they don't expect you to know it just from your revision, but they expect you to apply your knowledge to something new. So in this question, it's quite a long question just for 1 mark, but it talks about basically energy being stored in a large amount of soil and pipes, etc. Basically, they're going to be black, and the question says suggest why. So we can think of a fact that relates to this question. It's all about the top bit, you can see it's about melting ice on roads. So think of a fact we know to do with the fact that it's black and to do with stuff melting, or we should know that black surfaces are good absorbers of infrared radiation. So you won't have revised this question in particular, but you will have revised the idea different colour surfaces have different abilities to absorb and emit infrared radiation. So that'd be an example of a suggest question. Another one might be, this question is part of a bigger question to do with making a sort of circuit involving a thermistor and a Bunsen burner. We don't need that for this question. The question just talks about, it could be used as a thermometer, suggests 2 disadvantages of using this equipment compared to a regular liquid in glass thermometer. That means just ones you find in a science lab. And some of these can just be common sense, okay? So think of what the question tells you and what you know. This one is literally just common sense though. If you were to drag around a Bunsen burner and a beaker all day, that's not going to be a very good thermometer. So it's not portable, you can't take it with you, would be a good enough answer here for 1 mark. You could talk about it requires a lot of equipment, a lot of time to set up compared to a regular thermometer. You could talk about the fact it needs electrical supply. You can't read it directly, you need to sort of set everything up to be able to do that. So again, you won't find that in the specification, but because it's a suggest question, you've got to draw on your knowledge and, like I said, a bit of common sense to work out an answer for these types of questions. Another one we've got for suggest, this is to do with climate change. This could be on biology, chemistry or physics. So you've got a Paris climate agreement saying in the future some European countries will only allow electric vehicles. Suggest how this will affect the methods of electricity generation. So affecting doesn't say whether it's going to increase or decrease, it just says what is going to happen to them. So using our knowledge, we could say that actually we know we know sort of a bit about climate change, so we can talk about what kind of methods of electricity generation would help that. So the obvious one that we need to do more of is to increase the amount of electricity we're producing over overall the energy demand. How we do that is using something that doesn't emit greenhouse gases, so nuclear power, wind power, solar, whatever you want to talk about in this question. And the idea is so that carbon dioxide emissions don't increase. So now you've seen the answer. That doesn't sound like a bad question, but you've got to be able to pick on that knowledge to apply to a different scenario. The last two command words we're going to look at can be some of the trickiest. They're usually 3 or 4 mark questions, if not 6 mark questions. This one's about comparing. So it sounds easy enough, but comparing, you're making statements about 2 things. You've got to make comparative statements. Comparative means you say something, you've got to indicate, you're not just describing, you've got to say something is bigger or smaller, stronger or weaker, that kind of thing. So we've got 2 isotopes here. We've got carbon-12 and carbon-14. The question says compare the structure of the atom. So comparing the structure of the atom, we could talk about similarities and differences. They have the same number of protons, so you can say the same atomic number as each other. So that's comparing them because they're both the same. Also the same number of electrons because it talks about the atom, not just the nucleus. A difference between them, hopefully we can see the mass number is different. So it's a different number of neutrons. You could even say one has 6 neutrons, one has 8 neutrons. That would be absolutely fine to say with carbon. Evaluate questions. We're making comparative statements again, but almost always this will be talking about pros and cons or advantages and disadvantages. And with evaluate questions, they might say in the question, but they might not. You have got to come to a judgment about which one is better or worse, or which one meets the need, or whatever's in the question. So for this one, this example is from an AQA document they produced themselves a couple of years ago. It's a chemistry question about different ways of comparing fuel cells to rechargeable lithium-ion batteries to power cars. They give us, and this is AQA themselves giving us this, a model answer. However, the model answer doesn't contain a key bit. So the model answer has a lot of good stuff in there. It talks about hydrogen fuel cells, the sort of pros and cons, using the table to get some sort of comparative judgments. However, the downside to their answer is they don't actually come to a judgment. They don't say which one they should use. So therefore, this person can't get full marks or close to full marks in this question. So they should say something at the end like, I know I would use fuel cells because X, Y, Z, whatever. Okay. So these kind of statements they really need are, something is better, something is worse, and this is the best, or this is what I've described as being better. So therefore, this is the one I think that should be chosen. So like I said, this document, I'll link in the description as well. You can Google it yourself. It's publicly available just for AQA, but this stuff applies to all exam boards. They produced it a couple of years ago just to clear up any misconceptions. It goes through things like using bullet points, comparison tables, things like that as well that are really helpful. So this is all based off a document AQA produced a couple of years ago, and there's similar things produced by the other exam boards, just looking through exam technique and misunderstandings in science. So one of the big things that came out of it was things like being able to use bullet points is absolutely fine, and for comparison questions you can use tables. They even mention it in the question in the document themselves with an example, this one here. So it's absolutely fine to be brief. You do not have to use paragraphs. You obviously want to spell things correctly, but bullet points are fine, comparison tables are fine, as it mentions here. So definitely use these tips in your exam to make sure you maximise those marks. This isn't revision, this is just being smart in the exam to not lose marks. If you found this helpful, give it a like. I'll try and do another one with paper 2 content on it fairly soon.